This section is naming and writing molecular compounds. Molecular compounds are composed of two nonmetals. In this case, acids are being lumped in with the molecular compounds, and you can quickly identify acids in these problems by seeing that they're the ones that begin with H and they end with acid. So there's only two that are not acids in this example, and they don't begin with H in the formula, or they don't end with acid. So the two that are highlighted green are molecular compounds, and the others that are highlighted yellow are your acids. In this first one, the thing that you want to look at for this one is it ends in ic and has the prefix hydro. So when we go to the flow chart for writing the formula, we answer the questions. No, it does not have a charge. And does it have a prefix that's mono, tri? So no, it does not. Does the word end in acid? Yes. So we go down here. And does the name begin with hydro? Yes, it does. That's telling us it's a binary acid. So binary acid, naming it right here, or writing the formula, I should say. It begins with, you're going to write H with its charge. H is +1. Then you're going to write the second element symbol's charge based on the periodic table location. Well, what they mean by that is when you look at the name, the only thing that's left over is this chlor. So you have to try and figure out what element that is. You can go through the periodic table, and you're going to be looking on the non-metal section when you're naming acids. So you're looking for something in the non-metal section that has chlor in it, and that is the chlorine. And so you drop the last syllable and it's where we're doing the formula. You use the crossover method. Chlorine has a -1 charge, and you're going to use the crossover method. So it's hydrogen with a plus charge, chlorine with a -1. They cancel out like they are, so one hydrogen will cancel out the charge on chlorine. This is a binary acid because there's only two elements in it. All acids will have hydrogen in it, and the other element is chlorine. The next example has 3 elements in it, so this is going to be a ternary acid. So when we go to the naming part, we have 3 elements. So we go down here, and it asks the question, does it end in ate or ite? And it's talking about a polyatomic ion. So when we go back to this formula, the polyatomic ion is always going to be everything except for the H. So when we go through these examples, those are the polyatomic ions. So SO3 is what I'm looking up on the polyatomic ion sheet. And when I find SO3, I find out that sulfite is the name, and it's got a -2 charge. So it's SO3 with a -2 charge called sulfite. And so the name for this, when we're naming it, we're going to be, since it ends in ite, sulfite, we're going to be using this box where it says name the polyatomic ion, sulfite, ignore the hydrogen, and replace the ite with us. So instead of sulfite, we're going to call it sulfus. And acid, well, sulfus or sulfur is one of the exceptions to this about dropping the last syllable. For some reason, they keep the whole word, and it's called, instead of sulfus, it's called sulfurous. And then add the word acid. for number 37, what I want you to key in on is that it ends in ic and has the word acid, but there's no hydro on this. So let's go back to the writing the formula. And since it has no hydro, but it ends in ic, we end up right here in this box, and we're going to write the H and then replace ic with 8. So go and then find that formula on the polyatomic ion and use crossover method. So instead of astatic acid, we're going to look for acetate on the polyatomic ion sheet. So we know we're going to have hydrogen because it's an acid, and then we're going to look up acetate. So acetate acetate, the formula for it on the back or the polyatomic ion sheet is ATO3 with a -1 charge. And the ATO3 with a -1 balances out the charge on the hydrogen since they both have a -1. So when you write the formula for acetic acid, it's HATO3. Now, H3BO3 has a polyatomic ion in it, and it's BO3. So let's go look what the name of BO3 is. BO3 is called borate, and it has a -3 charge. So when we go here and we're naming this, we've got borate. And let's remember that it ends in 8. So when we go to naming this, we are right here in this 8 section, and it says that we ignore the hydrogen and look up the polyatomic ion, which we did. It's called borate. Replace 8 with ic. So instead of borate, we're going to call it boric, and we're going to add the word acid. So this is called boric acid. Boric acid. The next example, dihydrogen monoxide. I want you to look at the prefixes on here, di and mono, and they'll help us when we're trying to write the formula. When we answer the questions on the flow chart, we don't end up going to the acid section. At this question right here, we're going to actually answer yes because it has both di and mono in it. So we end up going down here to naming molecular compounds or covalent compounds. And it says write the first element, use the first prefix to determine the number in it. So di was 2, and then write the symbol of the second element. So that's oxygen, and you're going to write an O, and then use the prefix to determine the number of the second element. So going back, we've got di meaning 2 hydrogens, and mono means 1, and then oxide was oxygen. So we're going to write the formula as H2 because there's 2 of them and 1 oxygen. HF is an acid because it begins with H. So when we go to the flow chart, there's only 2 elements here. So we're going to end up in the binary section for naming acids. And it just says add the word or the prefix hydro. So hydro, name the second element, which is fluorine, except for we're going to replace the last syllable with ic. So hydro, fluor, ic, and then add the word acid. Hydrofluoric acid. Hydro, that tells us it's binary. fluoric acid. The next one, tellurous acid. Key in on the last three letters, the OUS. So when we're writing the formula, we're ending up in the OUS section. And we're going to write, follow this box, which is write H. H has a +1 charge. We're going to replace us with ite. So what they're talking about is the name tellurous. It's going to be tellurite. And we're going to need to find the formula for tellurite on the polyatomic ion chart. So when we go to the back, we see that tellurite is TeO3 with a -2 charge. So we've got TeO3 -2, and it's hooked up with hydrogen that's got a +1 charge. Those charges don't balance, and so we use the crossover method, and we put a 2 down below and a 1 down on the other one. And so our formula ends up being H2TeO. This last example, NF3, does not have hydrogen in it. And when you go through the flow chart for naming, you actually answer this question right here, is what does the first element begin with? A metal, NH4 hydrogen, or a non-metal. When you look up N on the periodic table, nitrogen is found in the non-metal group. So since it's over here with the non-metals, then you're going to answer that it begins with a non-metal. And that brings us down to the bottom for naming molecular compounds. Naming the molecular compounds, it says name the first element with its prefix. Well, prefix to indicate the number of atoms. Well, there's only one nitrogen, so you'd use the prefix mono. But there's a little note here that says you don't use mono for the first element. And then the second one says name the second element with the prefix to indicate the number of atoms. Replace the last syllable with "ide." So this one is nitrogen, and we don't add mono, so it's just going to be nitrogen. And there's 3 fluorines, so that's trifluoride. So nitrogen, trifluoride.